Are we live? Okay, I'll assume we are. So good morning, everyone. Thanks for coming to All Core Devs number 141. Couple things on the agenda today. First, just a shout out on Grey Glacier, which is happening next week. Then a bunch of merge related stuff. Then, like Client had a small issue around the debug namespace he wanted to get feedback on. And then finally, Paul from Lighthouse here has made a suggestion for changing the day that we have these calls on to be more friendly towards the parts of the world where it ends up being Friday night or Saturday morning. So we can chat about that at the end. There were two EIPs that we've been bumping from call to discuss and never had time for them. But then one of the champions has some issues that they're looking into for EIP 5027. But then for EIP 4444, there is also like an update that was posted on the GitHub there. So we can discuss both of those on the next call, but if folks want to check it out async in the next 2 weeks, so at least we have the context when we're talking about them. First, yeah, so Grey Glacier happening next week. It's expected around June 29th. There's a blog post with all the client releases out in them. If you haven't upgraded your node, now is the time to do it. I don't know if there's any client team who wanted to chime in about the upgrade. Okay. Yeah, update your nodes for that. Next up, moving to the merge stuff. We had our 7th mainnet shadow fork earlier this week. Perry, do you want to give a quick overview of just generally how the fork went? And then I know that like Besu and Nethermind had some stuff Besu and Aragon had some stuff they wanted to go over as well. But yeah, do you want to walk us through high level how the fork went?
Yep. So we hit the chain was launched, I think, last week on Friday or so, and we hit TTD around Wednesday after an override like a day earlier. We hit TTD a couple hours later, which I guess is a sign that hash rate is changing even drastically within like the span of a day. But irrespective, we hit TTD and we were finalizing for a while. I think we immediately dropped down to around 80-ish%. So about a 20% drop off on nodes. And over the span of the next 12 hours, a lot more nodes dropped offline. Later, we figured out that most of the nodes that dropped out were either Eragon or Besu nodes. As far as I know, the Eragon issue isn't really an issue, but rather something related to how shadow forks work. They're looking for a block, but essentially don't have a peer who's providing the block to them, so they get stuck. There was I think I had enabled the experimental overlay, and there was an issue with ETH stats that I had enabled on the config. So I removed both those flags, and since then, Aragon is progressing. I think we saw like 2 or 3% come back online. Hopefully more does come back online soon. The Besu issue, however, is a deeper one, and I'd let someone from the Besu team talk about that.
Yeah, I can take that. This is Justin from the Besu team, if you want me to go now.
Just 1 second. I think there's just one more update. I've updated the same tracker we have for checking if we're proposing empty slots. I don't have any data from Besu, of course, but from the other ones, the only combination that proposed an empty slot, so without transactions, would be Nimbus Aragon. So we're doing pretty much as well or slightly better than what we did with Roxton. So that would mean there's no real incompatibility right now, or there's no regression at least.
Nice. Yeah, I don't know if
that's about it.
Maybe, yeah, thanks, Barry. Maybe does anyone from Aragon want to go over to the peering one before, if this is like a bit simpler, and then we can do Besu in more detail?
Yeah, I can briefly describe the issue. The issue is not per se with the merge, but with the shadow forks, is because we don't have a network split. So we have peers from the shadow peers and upstream vanilla mainstream peers, and occasionally we don't have enough peers from the shadow fork, so we can not download block bodies or something like that, and Aragon becomes stuck. But I don't want to spend too much time because this shadow fork testing is a bit artificial. It shouldn't happen on real testnets or on real mainnet.
Would it be
exactly,
like
and so we also
sorry.
just did a small flag update. We just added static peers, and that pretty much solved the issue.
Right, then like for future shadow forks, is it like straightforward to just, we could literally peer all the shadow forking nodes together, right? Like that we run?
Yeah, I think from next time onwards, I just use static peers. That might just be easier.
Nice. Okay. Cool. Anything else on the Aragon side?
Nope.
Okay. Justin, do you want to walk us through what happened on Besu?
Sure. Okay, so with regard to mainnet Shadow Fork 7, we saw a long-running issue that the team has been tracking get dramatically exacerbated. I've attached a HackMD write-up that goes into much more detail to the agenda in the comments there. Feel free to read that and send any comments my or anyone on the team's way. But the nature of it has to do with our Bonsai storage system and a concurrency issue that we found in it. In the past, this has been fairly rare, and we've never seen it actually hit all of the nodes at the same time around the merge, like happened on Shadow Fork 7. We don't think this is merge related. We still maintain that this is a concurrency issue in Bonsai, and we have been working this issue pretty rigorously since it first showed up in late April. We've made a lot of progress on it, and we do have some ways to reproduce it now that we've got better Hive test adaption. The fallout, though, was Besu made up 25% of the network, and all the Besu nodes failed, so we started to fail finalization. Participation dropped. There wasn't enough to keep maintaining. We did continue to propose blocks, but all the blocks were empty. So that's not terribly useful. So this is an issue. We are tracking it. We have managed to make it worse, which we actually like because it makes us easier to reproduce. I think you all can appreciate how hard concurrency issues are to reproduce and analyze. We are continuing to work it. And if there's any need for greater detail, I'm happy to elaborate. And I hope everybody can get to the HackMD on the subject.
Thanks. I have a quick question. I know, I think Bonsai trees is like the default storage mode now, if that's right. But I assume that non-Bonsai storage still is supported in Besu. Is that correct?
Yes, it is. Forest is still supported. Forest is actually still the default. Bonsai
Forest is still the default.
Yes, Bonsai is no longer experimental. However, it is not the default.
Okay, and I assume just because like Bonsai is smaller from a disk size perspective, that's all we've been using for shadow forks. But
that's correct.
Yeah, and so I guess a quick fix there, and this might be hard for like mainnet, but it's like using, or actually no, because it's a sync. But like I guess a quick fix is we can just use some non-Bonsai nodes on the Besu side and see if those if those work smoothly.
Yes, we'd like to suggest next time we do a mix of Forest and Bonsai nodes for the next shadow fork. We've also discovered that this is more exacerbated when running in Docker. Our canaries that we run don't run in Docker, and we very, very rarely see this issue. We do see it. It does happen outside of Docker, but Docker does seem to exacerbate it, which kind of led some credence to timing and concurrency issues.
Right. Okay. Anyone have thoughts, questions on this? Okay. So it's encouraging. It seems like the two big issues we hit are like client issues, but not merge related issues. So that's good. That's progress. Anything else about the shadow fork in general?
Yeah, I would like to add that there was 10 Nethermind nodes, and all of them was successful on transition. And right now, 8 are still healthy, but on 2 we have 3 exceptions. Like both nodes with Teku are down for now, and are investigating what's going on.
Okay, so the Nethermind Teku pair is having issues.
Yes, but it was like day or even more than day after transition.
Got
Just
it.
to add to that, I'm working on a somewhat related fix, so this might get fixed by this, but we are not entirely sure if this is that root cause.
Got it. Okay. And I know there were a couple other merge like related topics around like latest valid hash and sync that we wanted to chat about. So I think it probably makes sense to get through those before we start talking about like the next shadow forks or Sepolia. Yeah, just to make sure we're all kind of on the same page. But yeah, anything else
before
about
we
mainnet shadow
switch
fork
to
7?
that?
Oh yeah.
Yeah, I have another update, but this time regarding Robston. So Sam from the EF DevOps team, unfortunately, he's in Australia and couldn't make it to the call, but he wrote a really nice write-up. I've just shared it in chat right now about the automated sync test that we have that he ran on Robston. All the code and the repo, Helm charts, everything is open source, so people can reproduce it if they want. Essentially, he syncs up to head on Robston on every combination. Then he runs complex sync tests. For example, stop the EL for one epoch and then restart stop the CL for one epoch, restart the EL, or do it the other way around, or fully sync EL and then start Genesis sync on CL and so on. Yeah, the results are there, and I think some tests need to be rerun, but essentially, at least the sync to head tests mirror the results that the ETHStaker guys found as well. And as far as I know, those already have open issues.
Nice. Anyone have questions, comments on that?
Yeah, I have one. So are those tests like available to be rerun or being run as somewhat like Hive test or something? That because we are still working on that code and we would like to, it would be great to have some kind of test to potentially spot regressions.
Exactly, they are. Let me just link to the repository. It's just a GitHub Actions thing similar to the nightly run. You can make a PR over there with whatever you want to change, and it should be reflected. So we have a sync test coordinator, and then it triggers off the sync tests by a GitHub action. And then the result of the sync test is also viewable on the GitHub action, but I thought it's easier to give an overview with a table instead. In case you guys have any questions about the setup, please reach out to Sam. He's on Twitter and Discord, and I can connect you if you need to.
Cool.
I also ran my own Robson sync test today, and what really stood out was that I ran Lighthouse Geth, and Lighthouse took 50 minutes to sync for I think 3 weeks worth of blocks now, and Geth took like 15 or 10 minutes, and so like the consensus layer sync is way slower than the execution layer sync, and just something to keep in mind.
I think the Lighthouse sync has a bit of improvement to do as well. We're adding some concurrency and starting to do some benchmarking about how fast we can sync with the merge. I think in general, the consensus sync is a lot slower than execution layer sync, but the checkpoint sync is kind of what we need. So hasn't been a huge target to improve syncing speeds in the consensus layer.
How long would you expect the checkpoint sync to how long do we need to sync with a checkpoint sync? Like 2 weeks or 3 weeks, or how often would we do the checkpoint?
We can usually do it since the last finality, so we only have to sync, like 6,400 blocks or something like that. I think Teku and Lighthouse will do a checkpoint sync in less than a minute, or around about a minute.
Yeah, but I guess in order to do a checkpoint sync, you need to manually feed it a checkpoint, right?
Yeah, you can also point to like another beacon node endpoint, and it can pull it down. So you can use like a centralized provider, or you can use another node that you have. Checkpoint sync is a requirement for proof of stake syncing, basically, for any period after genesis of a matter of weeks.
Well, yeah, of course, but I guess the idea is that somebody could post a checkpoint So my expectation with checkpoint sync would be that you put in a checkpoint and then you just use that for the next 3 months or 5 months or 6 months, and then eventually just choose another one. But I mean, if it takes super long to synchronize even from a 2-3 week old checkpoint, then it gets a bit annoying to always have to go somewhere and fetch it. So I can imagine most people will just configure their nodes to just look at Infura and do whatever Infura says, which kind of beats the purpose.
Yeah, baking in like a 3-month, 6-month checkpoint state isn't how it's gone with the consensus clients. There's been a bit of talk around it. I'm not sure if we want to discuss it now, but that's not the way it's gone. Yeah, maybe this is a good one for Discord or something like that.
Yeah, I mean, anyway, I think Marius just wanted to bring it up because there's this big discrepancy, and essentially the experience that people will have, people who are running Ethereum mainnet nodes currently, is that synchronization could become, even catching up could become super slow, and would be nice to at least not pile too much load on top from the beacon clients.
Yeah, I agree. It would definitely be better to make it faster. I think the staking community are pretty familiar and comfortable with checkpoint sync as well, though.
Yeah,
and this isn't only a problem with validators or stakers, though, right? This is a problem for anyone running a node.
Yeah, that's right. I guess the point I was trying to make there was that people who are used to running beacon nodes, or even people who've just started out running beacon nodes, seem to get to speed with checkpoint sync pretty well. They're definitely not saying we couldn't benefit from improving consensus layer sync speeds.
Yeah. Yeah, I don't think we're gonna improve the full sync spec on the CLs right now, but definitely something people should be aware of. And I don't know, I guess, yeah, we can continue this chat in the Discord, either in the consensus dev channels or Aqua dev. Just to take a quick step back, anything else, Marius, you wanted to share from just the sync tests you've been doing?
No, it was oh yeah, but before the merge happened, I synced with pretty much exactly 50 slots per second. And after the merge hit, I synced with 30 slots per second. So this is the engine new payload and Fox is updated. So yeah, that's the full sync with the blocks.
Got it. Thanks. And Andrew, I see you've had your hand up for quite a while. So
yeah, so about checkpoint sync, do we have Infura for Opston? Because to my mind, it's very important to check to test the checkpoint sync, because for the mainnet, it's pretty much a must. So we should definitely test it more on Ropsten and other testnets. And to my mind, it should be the default for like all public testnets. You can opt out, but by default, checkpoint sync should point to Infura or something. That's my thinking.
Yeah, it's always been pretty hairy putting Infura in as a default. That's why we've struggled to put any default checkpoint syncs in. I'm not sure if there's an Infura or a beacon and API provider for Ropsten. My guess is no, but I could be wrong.
I mean,
right.
Just mentioning that for Ropsten, for the testnet, it probably makes sense to just point it at Infura and not care, because the idea is it should be as pleasant of an experience as possible. But for mainnet, I think it would be a very bad idea, very bad public view to just point it to Infura.
So yeah, and I'm not sure that there is whether it's Infura or like another, that there is like API provider for the Ropsten beacon chain. Obviously, like a bunch of these support Ropsten at the EL layer. Yeah, and I also feel pretty strongly that like whatever decision on that front, that's much more of like a client level decision than like protocol level decision. So you could imagine Lighthouse using Infura and Prism using Alchemy, and like Nimbus not using anything, or like using something that they maintain. So yeah, I feel like this is probably it's not something I don't think we have the like checkpoints to do, but also if if we do, it feels like enshrining any single provider at like a protocol level spec feels quite wrong. But then clients are obviously free to do whatever they want in terms of like improving the UX for their users. And yeah, I don't know. Anything else on?
I was just going to say, it's potentially an interesting point that we might be under testing checkpoint sync on these testnets. From I'm mainly interested in it from a execution layer perspective. Just for execution layer devs, it kind of looked like your consensus layer just comes online, say like in the last say 128 slots of the chain, and just starts sending you payloads from there, and then syncs to the head, and then just waits for you to catch up. So maybe something to think about is trying to make sure that we test checkpoint sync a bit more with execution and consensus layer clients. I know at Lighthouse this is not something we've really thought about before. Maybe someone else has.
So that's essentially the preferred way to synchronize a guest node. Just give us the head as soon as possible, and we will figure out the rest. So for get, at least execution wise, the later header you can give us, the better. We don't care if there are gaps. I don't care about the beginning of the chain. Just give me the head, and I'm happy with it.
Yeah, it's similar for Nevermind.
And for Aragon.
So I think that's kind of all execution layers who can snap sync, warp sync, fast sync, or whatever. In order to do that, they need a header or something as close to head as possible. So that's kind of the expectation.
Great.
probably we should just pay more users' attention to using the checkpoint sync in the documentation or any other places.
I think the idea isn't necessarily that it's hard to use the checkpoint sync or that users don't want to use it. I think it's more like they have no idea how to use it or what to point it at. So if we could somehow make that obvious or some helpful, it would probably go a long way.
Can't a checkpoint be like downloaded through peer-to-peer? Like, why is it like you have to point it somewhere? I don't understand the design.
The point of checkpoint sync is that you provide a hash, a trusted hash or trusted checkpoint.
Yeah, so how it works in consensus clients now is that they go and query a beacon node API, so the standard HTTP API on beacon nodes, and then they get, I think most of them will get like get the finalized checkpoint, and then get a state, download a full beacon state, which is order of 100 meg, and then a beacon block, and then they'll start syncing forward from that. The idea behind it is it's supposed to be like from a source that you trust, so like your friend or something like that. How that turns out in reality is slightly different, but the reason that we haven't done it over the peer-to-peer network is for two reasons. One, because if you get eclipsed at the start, like when you're first booting, you don't have a great set of peers, and if you get eclipsed, then you'll start from a bad place, and you can never really correct from that. And then second is because it's just transferring that large state over the peer-to-peer network has been a bit of a challenge, and we haven't really got to it. Quite seen the need for it.
So actually, never mind. We have similar idea that we can optimize some things around this in terms of syncing, and we actually bake in that hash into our configs on every release, but we release fairly often, like every 2-3 weeks. So yeah, that's how we handle similar thing. We just bake in for every supported network hash. We have automated that.
That has also been discussed in consensus land, but it just hasn't consensus layer land, but it just hasn't happened that way. Might be a good kind of Discord conversation.
Yeah, because otherwise for mainnet it will be prohibitively slow. Like I strongly think that for the mainnet, checkpoint sync should be the default. Like whatever is used in Fura, baked in hashes or whatnot, but it should be the default.
Yeah, if you would have it baked in, then if even the user wouldn't specify something newer, you would have a fallback, right?
I think baking in a checkpoint thingy is perfectly valid. I mean, Geth has been doing that since forever for the live client. Since whenever the assumption is that whenever somebody downloads a new Geth client, I mean, they are trusting us. I mean, we are handling their keys, everything. So if they don't trust the code, then why even run it? So if their trust is there, then the code can actually ship something reasonably new. The only downside is that it's kind of a pain in the ass to update these checkpoints every 2 weeks when we do a release. And also, if you have a lot of people, what they do is that they upgrade Geth when there's a hard fork, and then they don't touch it until the next hard fork, which means that it maybe there's 6, 8, 12 months passed in between. So if you try to use the 12-month-old client to sync with an old checkpoint, then it's going to be hurtful. So in order for this developer trusted checkpoints to work, people kind of need to run the latest code, at least when they sync. And I still think pointing the beacon clients to Infura is a horrible idea that's going to backfire.
So like I said, I would use this way that I would bake in some defaults at the point of release and allow people to override it, of course, with something newer.
Yeah, that seems the sanest approach.
Okay. Anything more on checkpoints? Okay, but yeah, obviously we can continue this in the Discord, and yeah, encourage people to check out the document that Terrence linked in the chat, where Danny has gone through also some of the different approaches. Cool. Next up, Mikael, you wanted to go over some issues around latest valid hash. You want to give a bit of context on that?
Yeah. So latest valid hash, we have been discussing it like a while ago, and apparently there are some difficulties in supporting it, at least from what I heard, at least in Geth. Yeah, I just want. I think it makes sense to start from like somebody from Geth explaining what's the difficulties they have to support it as it is stated in the spec, and then just proceed this conversation.
I think just a quick recap, just to make sure that we're on the same page. The idea is that when we get, I don't know, new payload or set fork choice update, the idea is, I mean, the spec states that we should, if the beacon client tries to push us onto an invalid chain, for example, Geth nodes mined a really long invalid chain, and then the Nethermind client tries to feed that to the Nethermind execution layer, then the expectation is that the execution client starts processing this long sidechain, and then halfway through where it hits an invalid state transition, it just stops and returns that, okay, block 500 out of the 10,000 is invalid. This is the theory. Now the practice is, the problem is that this new payload or Fortress update, we are expected to return instantaneously to it. For example, we return that, okay, we don't have this chain yet, so we return syncing. That's nice and all. We have a 10,000 long chain, which halfway through is broken. So we say, okay, syncing, but by the time we discover that it's halfway through broken, we already replied to the beacon client. So we only know that block 500 was broken. And then, let's say 1 minute later, the beacon client says that, hey, here's a, previously it gave us a head to block 10,000, and now it gives us new block, head 10,001. But again, we have absolutely no idea what this block 10,001 is, so we need to start a synchronization up. Then we need to go back all the way back, and then eventually we will reach the same decision that, okay, block 500 was bad, but again, we had to reply much earlier. So we never have the response available to tell the beacon client that a block 5,000 blocks ago was invalid. So every time we figure out that there was a bad block 5,000 blocks ago, it's already too late to tell this to the beacon client. And the only way we could work around this would be to maintain an entire chain or set of bad blocks. And for example, when the beacon client tells me, hey, here's 10,000 blocks and the 500th is bad, then I would need to start tracking everything from 500 upwards to 10,000 as bad block. And then whenever I get a new Fortress update, I somehow need to link it in to check if there was this, in this set of bad blocks, if the parent is present there. If yes, I need to somehow figure out which was the origin of the bad blocks. And in general, it just gets a bit messy to maintain a big pool of bad things, because if the client works perfectly, everything is nice. If there's, for example, a data race or something in the client, then you could end up with simply blacklisting the canonical chain, the good chain. Because, and this actually happened at one point in Geth, where 3-4 years ago, the snapshots had the bug. And very rarely, a block was rejected for whatever data race, but if you try to import it a second time, it succeeded. So nobody really noticed it. I mean, we got issue reports that sometimes we got bad blocks, but the network didn't care because everything just continued. But so if we had a bad block blacklisting within the client implemented, then actually every single time one of those clients had this data race issue or hit this data race issue, they would have just dropped off the network. essentially gradually all the nodes dropping off the network because they would blacklist the main chain. And this is our concern, that it's not trivial to maintain it and track it, and anything that if something goes wrong, then it can have really, really bad consequences. And for example, this is the primary reason why Geth does not have any form of reputation management, doesn't have any form of bad block tracking penalties, so nothing the likes. And just another story, probably not many people here were present during Ethereum's Olympic test networks, but at that point, Geth did have blacklisting, every reputation management and everything on the network. And at some point, the entire network just fell apart into thousands of side chains. And eventually every single Geth node was on its own little side chain because there was some bug in the bad block tracking, and every node blacklisted pretty much everybody else on the network. So every miner was just mining their own little chain. It was a horrible show. And in the end, the solution was actually to just remove all the blacklisting and just try to be as robust as possible to bad things and try to reject bad stuff as fast as possible, but not track it beyond processing the request. So that's a very long background.
So the risk is, if we have this blacklist, and in particular, say in Geth, so the risk is to just mess up with it, to have a bug in it, and probably say that something like on the valid chain is actually invalid. Say this to CL client, it makes its own decision, so forth. I mean, did I get it right from your description?
So pretty much two things. One of them is tracking the bad blocks or bad chains is very expensive. If we do it in, I mean, we could do it in memory. I'm not sure how attackable that is or not. If we have to touch the disk, then it becomes super messy and ugly. And since tracking it is not necessarily super obvious, any mess up can have really catastrophic consequences. And the question is, what's the point? Why is it so important to be able to say that when you give me a block, I should be able to respond that 5,000 blocks ago the chain was bad?
Yeah, that's like another question. Yeah, but before answering this question, one thing my naive thoughts was just okay. So the client has all this like data. It's been fed by CL, and it follows eventually invalid chain, and it encounters an invalid block in the middle of the chain, right? But it knows what the tip of this invalid chain is. And yeah, the naive implementation that I've been thinking about is like, okay, so we encounter a bad block. Then we take this bad block, ask the downloader or whatever component is responsible for tracking the not yet synced, but syncing in progress chain, find the tip of this chain, and okay, store this tip and this bad block like a kind of just in memory, just in kind of a memory cache. Not persisting it to disk, and then when next time the CL sends a new payload, check that the parent hash and the block hash are not in this like invalid cache, right? So if it is in this cache of invalid tips, like of tips of invalid chains, then respond back with this information with the status invalid, and also add this latest valid hash, which can be like stored in this cache as well. So that was like naive thinking on it.
So one issue with that naive approach is that what happens if, for example, you give me a head, and for me to discover that there's a bad block, it takes me 10 minutes because let's say I have to sync from Genesis. And then I actually did discover that there's a bad thing. I blacklist your tip, so to say, but there are already 5,000, sorry, not 5,000, maybe 200 new blocks on top. So next time you give me a Fortress update, it's going to be So essentially, there will be in certain cases, there could be gaps between the stuff that you give me. So me blacklisting the tip is not enough because it won't, the parent might not be in this tip set. So it means that when the downloader starts processing, the downloader all of a sudden also has to be aware of this blacklist and constantly cross-check blocks against this blacklist. And that's exactly how Olympic fell apart. That was the exact implementation we had there.
Yeah, yes, right. And the assumption for this implementation work is that CL will be sequential in what it gives to EL. If there is a gap, there is no way to to link this to fill this gap, right, and to respond back correctly. So that was just a kind of assumption, and we assume that basically CL always sequential, almost always sequential. Of course, there could be failures, but if there is a failure, so it will just start syncing again with this chain, right? EL will encounter this bad block once again, and like second time, we assume that CL, if it failed previously, so you just should converge at some point.
So I think the catch there is that there's so you announce a head. I mean, the CL announces a head execution and it starts syncing. And then when the CL announces a new head whilst the execution is syncing, how do you handle that? Do you just move the new head? I mean, do you just update sync to the new head? I mean, that's what Get does. I have no idea what other clients do. So it's not super obvious, and that's a very specific implementation detail, and relying on all these little implementation details is a bit pushing it a bit far. I mean, it won't be as robust as it should be, in my opinion.
Yeah, I see. Okay.
I guess my question is, so at the end of the day, everything is solvable. The question is how much pain it is and why do we need it? So if there is some super strong reason why we must do it, then I mean, we probably can figure something out that we feel comfortable with. Maybe it won't be super robust, but something that we kind of can sleep good while at night with. But it would be nice to know why it's so essential.
Yeah. Yes, and that's the I think at the essence of this discussion. Okay, so why it's important? There is a risk. There is an attack vector. Basically, the risk of this attack vector is actually very low. It comes in a very, very particular network conditions when, say, network is not finalizing for some period of time, and the adversary has a portion of, I don't know, owns a certain portion of stake, or there is a bug in the fork choice, or both, or whatever. So there are some very, very particular conditions in which if EL clients do not support this latest valid hash as per the spec currently, the whole network, all validating nodes, let's suppose that neither EL is supporting this correctly, right? So it's always returns syncing. If CL sends keep following this invalid chain. So and if all validating nodes will be forced into the fork where there is an invalid block somewhere in the middle, we get the network of validators that are in never-ending syncing loop, and this is a kind of liveness failure that will require manual intervention to get recovered from. But once again, it comes with a very, very particular network conditions. It's not something that should happen ever on the mainnet, but still. So my intention and why I'm my intention of having this implemented across all the clients is that we just remove this vector from the table and don't care about it. So that's the reason why we why we have to support, why we must support this. I will not go in the details and the weeds of this like attack and scenario, like and the conditions, but we can do this. I mean, I don't want to spend time here like discussing it. We can do this offline in Discord or anywhere else.
Okay.
Lucas, Lucas has had his hand up for like 10 minutes. Was this related to the same topic?
Yes.
Yeah, okay, yeah, go ahead, please.
So I just want to say that we implemented this in Nevermind. I think we still have some bug or two with the sync scenarios, so don't treat it as final or production ready or anything. But we definitely do something like Mikhail explained, that we have a very simple cache in memory. I think currently it's 512, when we just keep a hash of the block and last valid hash for that block if there is a detected that it's wrong. So when we are syncing, when we detect the invalid block, we go through all the descendants of that block and mark them with that last valid hash. So we are keeping the tips of the chain marked. If it's longer than our cache, we are keeping the tips of the chain marked, not just one tip, but like potentially up to 512 blocks in that tip, which we considered good enough. So when the new one comes build up on this one of those blocks, we will be able to respond with last valid hash. So if the consensus layer is, let's say, sequential enough, we will have eventual consistency here that we will be able to respond with last valid hash. But yeah, that's how it's been built. The one big potential issue is with state sync. If we state sync, and the problem is with the state in terms of why the block is bad, like the state root doesn't match the state, we won't, in some of previous blocks, we won't catch that. That's, I think, the only scenario in mind that we cannot really detect invalid hash with state sync, with snap sync or fast sync.
Yeah, but I mean that's kind of the no limitation of fast sync, snap sync, warp sync, everything that you start. So the assumption is that when you finish the first initial sync, then the head block was fed to you was valid.
Yes.
And if that doesn't hold, then I mean all bets are off, and you're on the wrong chain, and there's no coming back. But the point with these initial syncs is that you do it only once when you start up your node and never again. So it's extremely hard to attack it because somebody needs to be listening exactly at the correct time and on the correct network, prepared with the exact attack vector, just tailor-made for that specific chain condition. So it's an extremely unlikely vector.
Yes.
Not really relevant.
And yeah, this like risk of this attack is only this kind of attack makes sense only on fully synced and online nodes. So it's definitely what we would like to prevent is only related to the block sync when the client is executing blocks, not the state sync.
I have a question. What happens? So let's say you feed me an invalid chain. I remember that this chain was invalid and the last valid block was 5,000 blocks ago. The next time when you tell me to import its child, I will tell you that, okay, the last, 5,000 blocks ago, we got a bad block. What would be the reaction of the consensus client? And specifically, more interestingly, what would happen if I would add a heuristic that once I returned that this chain is invalid, I will actually forcefully forget it that it's invalid. So if you try to feed it to me the third time, I will again do the processing. For the fourth time, I will report it's invalid. For the fifth time, I will again do the processing. For the sixth time, I will report it's invalid. The idea would be I would tell the execution client, sorry, the consensus client, if I consecutively twice hit the same issue, I can actually tell it that, okay, I'm hitting the same issue, but I would actually give myself the chance of reprocessing it and maybe getting out of some weird data race or some weird scenario. So would the consensus client choke on such a behavior or not?
So the consensus client will remove this chain from starting from this block from the fork choice, I guess, and from the disk if it was persisted, and will rework to the other chain, which is valid. That's the expected behavior. I don't know if in the next time when I think it's implementation dependent, but ask to consist the client developers, if this same chain will be given once again to on the consist layer, will it follow? Will the consist layer client start following this chain and do the same actually? I mean, encounter the same. Yeah, but I guess what happens in this case is that execution layer client will already have a state, right? And yeah, and if the same block is given once again, then it will just be invalidated instantly.
For Lighthouse, we would, if the EL told us that it was invalid, we'd remember that it's invalid. We'd mark that entire chain as invalid, and we wouldn't try to apply anything to it again. And any time that we were told that if we were told then again that it was actually valid, we'd log an error saying that you told us that it was invalid, but it's actually valid now. So there's a consensus fault.
Yeah, so my expectation wouldn't be that I will tell you that it's valid. Rather, I have this. I'm really afraid of tracking blacklists because my experience is that they can sometimes they go horribly wrong. So my idea here now was that if we were to add some form of blacklist, then ideally I would add a super aggressive expiration or eviction to that blacklist so that it would get thrown out very, very fast. So if you keep trying to feed me the same bad stuff over and over and over and over again, then occasionally I would like to be able to just say, okay, since you're pushing it so hard, let me just redo it. Let me just retry, recheck. Maybe something went wrong. And with such a behavior, I could accept such a behavior because then if there's some data race or something like that, there is a chance to somehow escape from that stuck state.
So Peter, I get what you're saying, but we are not, for example, blacklisting nodes, but we are blacklisting logs that we kind of failed on validation or processing. So validating the state root. Do you think this is recoverable in any way? I don't see it as recoverable.
No, that's actually happening in Geth. So that, as I said, about 4 years ago, there was a bug in Geth where there was some, I think either when I implemented the pruning, in-memory pruning, or when we implemented the snapshots, there was a point when essentially very rarely a block would get rejected because something else was also mutating the try or touching the try. And if you try to re-import the same block, then it succeeded. I think it was the block processing concurrently with pending block execution. So there was this weird scenario where two executions were running at the same time and corrupted the try. But if you actually tried to re-import the block, it succeeded because it was super rare for that to happen.
Okay, that's a valid scenario for a bug. I fixed few other things like that in Nevermind already, so I see what you're saying. I'm not sure if we could recover as easily, but maybe we could.
Yeah, we should probably continue this discussion some other place. But before we finish with the latest well-hash, I have a question to Basil and Aragon. Do you have any difficulties in implementing this as well?
We have implemented some basic caching. So yeah, you have a cache of invalid blocks, and for each invalid block, you have the last valid hash. But it's kind of, it's not very elaborate.
So maybe it makes sense. We have a testing call scheduled Monday to use that to like focus on this some more. And obviously we can use the Discord like in the meantime. But yeah, it seems like clearly spending more time discussing this on a call is probably valuable.
If I can have one last comment here.
Of course, yeah.
Because it's in memory, never mind. So restart, if we like blacklist something incorrectly, the restarting would erase the blacklist, restarting the node. So that would be a recovery scenario.
Got it.
Yeah, that's a good one. And also, I think, yeah, we should continue it elsewhere. And yeah, one of the options, I think that I'm like in strong favor to keep it as is in the spec and require these clients to follow these requirements. One thing that we could probably do if it's really hard and difficult to implement in some clients, we can accept that it will be implemented somewhere soon after the merge. Because as I've said, that the like risk of this attack is really low, and it comes with like very particular networking condition and so forth. So we can probably remove it like from the critical path to the merge. But I would strongly be in favor of leaving this in spec as this. And also, yeah, the Hive test that we have, if we like keeping this requirement in the spec, so we have the Hive tests in place, just accepting that some Hive tests that are related to this particular issue will just fail for the clients. This is the one of the options that we can take.
Okay. Yeah, I think that makes sense. Yeah, so let's continue this conversation on Discord, and then on the testing call Monday, and yeah, we'll follow up from there. But yeah, I don't think this is something we're going to resolve in the next like 5 minutes. Yeah, thanks, Mikhail, for bringing this up, and the client teams for sharing all the details related to the implementations. Any final thoughts on this before we move on? Okay. So I guess, yeah, the next thing we had was basically Sepolia, and how we feel about moving forward there. I guess at a high level, the Sepolia beacon chain is live. It's run through Bellatrix, so it's basically just waiting for a TTD to be set. Sepolia is also a bit different from Ropsten and Gordy in that the validator set is permissioned, kind of like Gordy was pre-merge, or sorry, Gordy is today on the execution layer. So it's much easier to coordinate like a network upgrade there, because yeah, the node operators are kind of large entities that we can reach out to. Yeah, so I guess I'm curious from client teams, like, I know on the CL call there were talks about potentially merging Sepolia sometime in the next week. Yeah, I'm curious to hear from like EL client teams what do you all feel is like a good timeline to merge Sepolia? Yeah, Lucas.
So we are planning a release with some fixes next week. It would be great if it was after that release, so we can test that. But so yeah, either late next week or week after that is fine for you. Early week after that is fine for us. But yeah, that would be great if we could have it in.
Yeah, we concur from Besu's side as well. I think our consideration is that we don't want to overload the end of next week, seeing as how Grey Glacier is going to be going out. But yeah, either before or after, with a slight preference for after.
Okay. Geth, Aragon?
Yeah, I mean, for Geth, it's just about setting the TTD and doing the release. We can do that whenever It just our request would be that it would be nice to give people a heads up of, let's say, maybe a week that, okay, here's the new release, run this for Sepolia.
Okay.
So if we have a TTD, then from my point on, we can just do a release the same day or the next day. And
okay. Aragon?
Yeah, so the same in Aragon, we can make a release relatively quickly. So no hard preference.
Okay. In that case, would it make sense? I don't have a TTD value now because I wasn't too sure of the date. But would it make sense if Monday I can come up with a TTD value, and then we have client teams put out releases like ideally around midweek. So if it was like Wednesday, so that like Thursday we can announce it, and then we can fork sometime like mid the week after that. So there's like roughly a week. I wouldn't fork, by the way, the next week. Sorry, 2 weeks from now on the 4th of July is a big holiday in the US. So we probably don't want to fork on the 4th of July. Or like, yeah, so maybe like, you know, in the couple days just after that. Yeah. Peter?
yeah, because only just a quick note. Last week, we also configured the DNS discovery for Sepolia. So I don't know which clients support it. I think many exhibition clients support it, but the TLDR is that you can also point it to Sepolia to run discovery,
Nice.
DNS discovery in Sepolia, and it should work. And it should actually help a lot with finding peers, because previously it was kind of annoying to find Sepolia peers.
Yes, I complained about this on Twitter, and everyone was sending me their e-notes in my DMs. So glad to see that this is going live. Cool. Yeah. Okay. So let's do that then. So by Monday, I'll have suggested TTD. I'll share that in the Discord. Get like a +1 from all the client teams. And we'll do like we did on Robston. Basically, the TTD will be like very high, such that like it's unlikely we would hit it ourselves. It's unlikely we would hit it with the rate, but then we'll rent some hash rate to accelerate when it actually gets hit. And so, yeah, we can have this value shared on Monday to teams, and teams have a release out by like mid next week, late next week. We announce this, and then mid week after that, like around the July 5 or 6th, we can have the fork happen on Sepolia. Anyone have a?
Yeah, I have a request. If we're going to do the same thing that we did for Robston, please. So with Robston, the whole mining was a bit of a pain, because essentially the hash power pointed to the mining machine just overloaded the mining machine. I think it overloaded the mining pool. And I think Mario was saying that essentially there's no really good open source mining pool. So it's kind of, the expectation is that you won't be able to throw too much hash power at it without it choking. So TLDR, let's not rent out 200 GPUs and throw all of it and then wait 3 days because the whole hell breaks loose. So
yeah, we can maybe also like start, because we have a bit of heads up too. We can start renting some gradually as well. So yeah, it doesn't have to be all as close. And it's like, if we rent some and then we see other people are mining, we can obviously turn off our rigs. So yeah, we can definitely try to make it a bit less chaotic this time around.
Or alternatively, what we could do is to, running a Sepolia node and probably a mining pool is fairly light. So maybe we could, if we want to rent out a significant number of GPUs, then maybe we could spin up, I don't know, 2, 3, 4 mining VMs and point the rigs to different VMs so that neither of them is super overloaded.
Right. Yeah. That seems like something that's pretty.
Probably renting one of these VMs costs, I don't know, $0.50 an hour or $1, so it's not really relevant for.
Yeah, that's not the cost. Yeah. Okay. Yeah, that makes a ton of sense. Yeah, and I might ask Mario to ping you, Peter, to chat about that some more. But yeah, definitely something we can do a bit smoother than the last time. Okay, so yeah, that makes sense. So let's aim for like a merge date for Sepolia of July 6th, more or less, plus or minus a day, and then having client releases out by this Wednesday, ideally, so we can announce things on Thursday. Yeah. Cool. Anything else on Sepolia? Okay, and then one thing I did want to get back to from earlier is shadow forks. So like we have obviously the mainnet Grey Glacier fork. Oh, sorry, Peter. Is this about Sepolia?
Yes, just a quick question.
Yeah, go for it.
So with Sepolia, there was a discussion on how to avoid the not enough ether issue that appeared on Gurley. And just a question, was that solved on the Beacon client side?
Oh, right. Like, yeah. So I think, well, Perry, yeah, do you want to give an update there?
Yeah, I can. Yeah, it is solved on the Beacon client side. Essentially, what we did was set the balance value of each and every validator to be 1 million at the Genesis state. And it looks like that inflates the supply by about 1.5 billion. So 8 times what it is. And there are a couple of other nozzles that we can turn to ease the pressure over the coming years. I made a comment on that on GitHub. I'll try and find that for you because that has a more concise explanation.
Mm-hmm. Yeah. Cool. Okay, then I guess the only catch is that we need to survive with the pre-allocate the Genesis allocation to the teams until then. So yeah. For public faucets, essentially, I think every team was allocated, I don't know, 100 mil or something like that on during the Greece meetup, and maybe every team could contribute a bit to the faucets.
Yeah, I've been doing that, by the way. So I've been sending a couple million Sepolia ether here and there to various faucets and people. So there will be more and more faucets like spun up in the meantime. But I think we'll survive with the Genesis allocations until we basically have withdrawals shipped on Sepolia, and then from that point we'll get basically infinite inflation from validators, or very high inflation from validators. Cool. And yeah, Perry shared a link in the chat about this. Okay. Yeah. The next thing I wanted to chat about was shadow forks. So if we have Grey Glacier next week and we have Sepolia the week after, do we also want to schedule a shadow fork in the next couple weeks? I don't know, Perry, do you have thoughts on that?
I have a thought on that. My thought on that is that yes. So since the shadow fork from yesterday was an epic fail, I think the fact that we are pushing the testnets shouldn't mean that we should skip on pushing the mainnet. Since I mean, pushing the testnet isn't too much of an effort, at least from a client developer perspective. Probably from Paris' perspective, it is. But still, I think as long as there are no issues with the mainnet shadow forks, we should hammer it and not wait.
Okay, and I guess then the two things that would be neat to do on the next shadow fork is one, run Besu not in bonsai mode, and two, like manually set peers or statically set peers on Aragon to make sure that they have some shadow fork peer. I guess, yeah, that's a question to you, Perry, mostly. Like, what's a realistic like time for us to get that set up?
I think Besu here would prefer maybe a mix of forest and bonsai. We plan on having fixes in that next build for whenever Perry's ready.
Okay.
Yeah, I can work on configs on Monday or Tuesday. Usually the nodes take a few days to sync because I'm in that, and we can have the shadow fork probably the Monday or Tuesday after.
So yeah, so we'd have the shadow fork basically at around the same time as the Sepolia fork, like
Exactly.
maybe a day before or after. Okay.
Yeah, the same week instead. Yeah.
Cool. Yeah, that makes sense. Peter, is your hand still up for something else, or? Oh, okay, perfect. Okay, so yeah, so expect a shadow fork, not next week, but then the week after. Okay, we only have 15 minutes left, and there's like two things left on the agenda. So there's the debug one from my client, but I know, so Paul had one about the awkward devs time, and I want to make sure we get to that because it's basically middle of the night, Friday to Saturday for Paul. So yeah, anything else? I guess before we do that, anything else just like on the merge or shadow forks? Otherwise, I think we should go over Paul's point and then wrap up with like client. Oh, Andrew?
Yeah, I have one question on the merge. I think in Geth, like I've raised this issue that some CL clients use network ID instead of ETH chain ID, but by the engine API spec, we should only enable expose ETH methods. So, but the problem I saw on Discord is that in Geth, for some reason, ETH chain ID doesn't work before EIP 155 transition, but can we somehow solve this issue? Because I mean, we could either make ETH chain ID available from the start, or decide that, okay, just let's expose network ID.
From Lighthouse perspective, we're using net ID at the moment, and it's just kind of like a mistake. We're getting rid of it. We also come across Geth not supplying the chain ID for a while, but we've just kind of worked our way around that. I'm not sure if there's any other CL clients that are having different troubles, but I guess for Lighthouse, things are kind of fine as they are.
Okay.
Yeah, I mean, I think the idea was that before you have a chain ID, so I don't know, this is probably more of a legacy thing that when the whole chain ID was introduced, then before the fork, it just returned nil because there was no chain ID, and then after the fork, it started returning the chain ID, and probably we just went with it. Yeah, I guess the interesting question is what happens. Maybe it was also a bit of trying to guess the future. Will we ever change the chain ID? Probably not. Yeah, I think it's kind of a semantic, philosophical question whether we should return the chain ID before it or not. We can probably return the chain ID from the get-go. It's probably fine.
Mikhail?
Yeah, just quick thing. There is a PR into engine API. EL clients under certain conditions may skip the fork choice updated processing. And this PR makes a little bit of change and in terms of like making it more precise, these conditions. Please, EL client devs, go and check this PR. And if your EL client, how it's currently implemented, is like broken by this change, just leave a comment. That's all. Cool. Yeah, otherwise it will be merged soon into the spec.
Okay. Anything else on the merge? Okay, Paul, the floor is yours.
Oh yeah, sure, thanks. So I was just pointing out that for a lot of Asia Pacific, this call is kind of at times between say 10 p.m. And 2 a.m. on Friday night. So that's places like China, Japan, Singapore, Taiwan, Australia, New Zealand. I think that it's not a great time in terms of work-life balance for people. It's just kind of, Friday nights for socializing, Saturday mornings for family. I think also if there were any times for bad decisions to be made, it'd probably be between 10 p.m. and 2 a.m. on a Friday night. So not great for decision making. Yeah, so I thought just bumping it back, say like 24 or 48 hours or something like that would be a huge help. Another point as well is that for places in Asia Pacific, so this is Friday night, so the next working day for us is in 2 days. So actioning things the next day is quite hard. It's also quite difficult like if you want to listen to the recording the next day, you need to either do it on the weekend or wait until the next day. So yeah, I'm just proposing that we can. I mean, I suggested pushing it back 24 hours. Someone else said do it 48 because people like to drink on Thursday nights. I don't know. I'm not really sure. People like to drink all the time, but I think at least Friday nights are clearly, should be kind of sacred times in the 5-day working week. So yeah, that's my proposal. Same time, but just 24, 48, 72 hours earlier. Please, respectfully.
Yeah, thank you. And yeah, and worth noting, obviously the CL calls happen on Thursday, basically. So that's a natural kind. If it would be nicely aligned if like this was also on Thursday, because it's like people know every week on Thursday there's one or the others. I guess the main stakeholders here are client teams. Like I'm curious to hear from like the different client teams. Could say Thursday 14 UTC work for you? Okay, so Marius is fine. I guess, does anyone on like a client team feel strongly that like this is not a good idea?
The only thing I really like about this timing is that afterwards I can go to the weekend. It's like a good end of the week.
What's wrong with doing that on Thursday?
Oh yeah, I could just end my week on Thursday.
You can still go to the weekend after 1400 UTC on Friday, but yeah, I agree. It's a nice way to wrap up. Okay, it doesn't seem like there's any objections. I personally prefer, like, Thursday is my favorite proposal. Like, one, because it aligns. One, because it aligns with the CL calls, and two, because it does give us like one day after to follow up on stuff. Like, I also tend to find that's like an issue because I ping everyone after this call about different things, but it's basically already Friday night in Europe, and so people don't respond to my messages. So yeah, I'd like to do that. I think what my like preferred probably way to do this is to just like have the next all core devs be the last one ever on a Friday, and so people kind of get to a heads up. Like, we typically try and not like change things. Like, if I don't know, if somebody in the next 2 weeks comes up with like a really good objection for this, I think it's fair to leave them some time. But yeah, I would basically make the next all core devs the last one on Friday, give a heads up that like after that it'll be on Thursdays, and then yeah, have it at Thursday 14 UTC. Last call if someone has an objection. Okay, well, yeah, thanks a lot, Paul, for coming on. Yeah, let's do this.
Yeah, thank you very much. Much appreciated. Really do appreciate it.
Cool. And last thing on the agenda, Light Client, you had a proposal to standardize debug namespacing across clients.
Yeah, just a quick thing. This has sort of come up in a couple of these like in-person interop situations where we're trying to test why different clients are having different issues. And we've talked a bit about having like certain RPC endpoints to retrieve information. I think in Amsterdam at DevConnect, we talked about maybe having one to get the raw receipts from a block. And so just like over time, there's been a handful of these different endpoints that would be nice just to have as a like standard across clients. And so I have a proposal to make 4 of those standard under the debug namespace. And the idea would be that each client just implements this, these RPC endpoints, and they're all conforming to a spec. We have this open RPC spec. If you haven't seen, I'll post a link to the PR. And that way we'll actually be able to run tests against these endpoints in Hive to make sure that everybody conforms to it. And I think this is just, not only is it nice having a standard interface across clients, but then we can build some more tools on top of those interfaces to help debug clients without having, individual behavior for each endpoint. So if some EL teams could take a look at that proposal and just like let me know what things you've already implemented and what things you would like to see implemented or maybe you don't think makes sense in this like super easy debug namespace, that would be really helpful.
Are you looking for feedback on like things that would be useful, or should it be constrained by things that would be useful and are relatively easy?
Right now, I feel like it was better to go for things that are useful and relatively easy. Just, I don't want to put more work on people, but it would be nice to have this as soon as possible, just so that there's, less interface for people to worry about if we're trying to debug like more of these issues in test nets. And so that's kind of why these ones that we have are just basic getters, stuff that like a lot of clients already have, but useful ones would be helpful to know as well. I would open an issue on the execution APIs and we can talk about it there.
Andrew?
So it says that Geth supports all of these. So my why can we simply use the current Geth interfaces as the basis? Is there a reason to deviate from Geth's interfaces?
I mean, we can, but there's the get header RLP and get block RLP only take in like a JSON integer, which is just different than all the other RPC endpoints. They take hex strings. So I went ahead and took the liberty of just making that conform with the other types of numbers that we take in.
Yes, I guess with the specification, the idea is that all the clients can just tell what they would like to see and how they would like it to work. So it's not just Geth enforcing its. So these methods that are in Geth, we just implemented the way we did because whenever we debug something, we needed it and we just hacked it in. They weren't particularly well thought out. And now if you want to standardize it, then it would be nice to actually put 10 minutes of thinking behind them before just blindly implementing whatever Geth has.
I have a comment about debug get bad blocks because it's not trivially to implement correctly. So one implementation that I think we have in at least PR in Nevermind, but we haven't measured yet, is just to keep it in memory. But then if you don't have the debug enabled module, you have to restart the node to enable it. Potentially we can add JSON RPC on admin module to enable the debug module, but again, admin module is also disabled by default. So when you restart, you lose this cache and you lose these bad blocks. Potentially you could store them in some database persistently. I think Geth does that. But then again, you need to prune them potentially, which is like creates a lot of complexity. I'm not entirely sure if we want to have it in a standard.
So we do not store it in a database, as far as I know. We just store it in memory. The only thing is that Geth, so if you attach to Geth on the IPC, then all the APIs are available always. So if it's not exposed on the RPC worst case scenario, I can just attach to the Docker container directly and pull it out from there.
Okay, and the IPC is always exposed?
IPC is always exposed, unless you explicitly close it down.
Is there a reason Nethermind doesn't expose debug by default?
Yes, if your endpoint is public, then it can cause a lot of load on the node.
Yeah, but I guess the question was why not expose it on IPC? So HTTP and WebSocket Geth is also very restrictive, but on these Unix sockets, if you're already on the machine within the Docker container, then it's already game over.
Yeah, truth be told, we added IPC only like a year ago and didn't really think about configuring it this way. It's disabled by default, so you might want to enable it by default and expose all APIs there.
We can talk about this somewhere else since we're close on time, but my initial reaction is I'm unclear what the attack vector is, where having debug exposed publicly is more problematic than having the ETH exposed publicly. Like if someone wants to take down your node that's exposed publicly, you can just hammer pretty much any endpoint and you're gonna drop the node eventually.
If you have set head exposed publicly, then you can just arbitrarily.
Sure. But set head is crossed out, I'm assuming, for this exact reason.
Oh, okay.
Right?
You're just saying, yeah, the ones that we have provided.
The getters.
I think I don't see a problem with it, but I see like with get bad blocks, that's a little bit more dependent on what the client sees on the network. And so it's possible that if you're trying to run a proxy in front of several clients, you might have different responses based on which one you route the command to.
Yeah, you would have to go ahead, Peter.
Sorry, you would have the same issue if you have two clients with mismatching chains that every time you request a block, a header RLP, you get a different answer. So I think once you start hitting debug, you don't want load balancing in there.
Yeah, like mentioned, there is a set head generally available, so we might want to like either move that or to like admin module or something. And if we want to make debug public, we need to review what's there and potentially remove some things from debug module as.
Yeah, the list of methods is just 4 methods right now. It's in the link that I sent.
Yeah, and I would definitely only advise making debug public if it is getters only. If there's any writing, then I agree they should not be public. Wait.
Yeah, I think we kind of agree. We all agreed and discussed that the debug namespace should be just a read-only thing, so that you don't have to care. And Marius had a really nice idea to what to call the chain modifier namespace. You can call it hey node, and then you just hey node.setHead. It was a joke.
Okay. Okay, I guess we're basically at time. Matt, I guess people can go to the PR there. Is there? Yeah, that's probably the best place to keep discussing.
Yeah, that or the JSON RPC API channel in Discord. I'll be watching both.
Okay. Cool. Any final thing anyone wanted to bring up really quickly? Okay, if not, the last thing, I'll just share is like the 2 EIPs that people wanted to discuss that we're moving to the next call. There was an update on 4444 and 5027. So those are both linked in the agenda if people want to have a look, and we'll try to get to them on the next Alcor Devs. But yeah, thanks everyone for coming.
Thanks.
Thanks.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye.
Thanks, bye.
Everyone. Thank you.